Okay, so I'm going to do integral of x e to the x dx. Okay, so first of all, I'm asking you to take the integral of this. Can I take the integral of that? Cannot. Why not?
Because you're a no.
Because I wrote no, but why not?
Because there's two variables of the same
Well, I
size.
could either set this to be u, in which case this has to be the integral of this, or the derivative of this, right? Or I could set this equal to u, in which case this has to be the derivative of this. Neither one work, so u substitution doesn't work. We got no plus in the middle, so I can't separate in two pieces. But, and here's where things are interesting, are both of these things you know how to take the derivative of independently? Then usually that means we got an integration of parts situation. That's what you're going to recognize. So I know how to do this, and how to do this. I know how to multiply together bothers me. Okay. Okay. So usually the first thing I'm going to do is I'm going to take the more complicated form of the two. I'm going to say that's going to be dv. Okay. Sometimes it doesn't work. Sometimes you have to flip what you're doing. It's a guess. Okay. I'm going to say dv is equal to e to the x dx. Okay, so I take the more complicated function, then I take the derivative of, and I attach the dx to it and write it like this. So far, so good? All right. So now I want to know what v is. So I'm going to integrate both sides. And I get v is equal to e to the x. So far, so good? Okay.
You ignore the plus c.
What?
You ignore the plus c.
Yeah, the c's are going to appear and disappear throughout this process. We don't need to worry about them. Okay. What happens at the end of the day is we're going to end up with a plus c at the very end. It's going to be all these c's added up and divided and subtracted and squared and whatever else happens to them. We don't care. Eventually, we need a plus c at the end. Make sense?
Okay.
Okay. So far, so good. Okay. So if this is v, then as we remember for the first page, we're going to do the integral of u dv. Let me double check to make sure that's the format they use. 'Cause one year I flipped it into v to u and spent the 60 minutes trying to undo just that. So this is the way. So if this is dv, then u has to be equal to x, correct? So then the integral of, if these are the matching functions, right? Then if this is the dv part, then that has to be the u part. Make sense? Okay. So then therefore, what I can do is I can go, okay, so the integral of u dv is equal to uv minus the integral of v du. So far, so good? Okay. So u we just said is x. V we just said is e to the x minus integral. What's v? E to the x. Now I got to figure out what du is, right? So that's the derivative with respect to u. How do I figure that out? I take the derivative of u, which is just x, right? That's equal to 1, right? So it's going to be 1. Actually, I did that. Be better to do it this way. Clean that up better. Let me look at what I did, because otherwise I'll get myself confused again. No, I just did it the same way. Okay, never mind. Thought I had a better way to do this. So derivative with respect to x of u, right? Okay. So then I go derivative with respect, so that's derivative with respect to x of x equals 1, right? And then I move the 1 up, and I get the derivative with respect to x, which is what I started with, and for this case is unfortunately equal to 1 dx. It might not be. It might be something else. Okay? So this step here, we're taking the derivative to figure out what this is, and so this becomes 1 dx. So far, so good? Did that badly? Okay, and this is x e to the x minus the integral of e to the x dx, which in this case would just be e to the x. And I've got an integral I couldn't do a second.
Okay, wait. What is the? When do we get 1 over? That's an ln, right?
Sorry, what? One more time.
No, if
So
you take
e
the
to the
derivative
x
of
is e to the
ln,
x both ways,
Right.
positive both ways. And then the
That
derivative
x to
of
the
ln
negative 1 is what gives you the ln.
yeah.
when you integrate that.
Integrate that, yes. Because he gets the
So the
x to the
derivative
0.
of ln x is 1 over x.
Yes. All right. So far, so good. Oh, then I have to tack on the plus c because we're
Yeah.
doing makes good.
So if you took the derivative of that answer, you'd get the original one.
Well, we should, shouldn't we?
Yeah.
And think about that through. Let's do it. No, let's not do it. Let's do it. No, let's not do it. What do we
It
get?
really look like you'd get it though.
I don't know. Let's figure this out. So derivative of this would be equal to that. That makes sense. Let's try it. I don't know if I've ever done that before. So we would go derivative with respect to x of x e to the x minus e to the x. Can I drop the c because it's going to go to 0 and become 0. Okay. So this becomes by product rule. I have to do x times e to the x plus 1 e to the x minus
do
whatever
minus
that is
the
e to
x,
the x. Bam, bam. It works. Whew. I was with you for a second, like, whoa, that doesn't really work. Better work, otherwise we got problems.
Yeah.
Make sense? Okay, so this process requires practice. Just requires, and as you get better, you'll get better at recognizing which one you want to set to be dB. Typically, it's the ugly part, not always. Not always, okay?
We usually make
Usually, if I look at the two things, go, which one's slightly uglier? That's the one I attach to the dx. Okay, and then from there I run the table. If I make that the dx, I integrate that one. I take the derivative with respect to the other one to set what the bound over here is, right? And then it's just run through into it. If you do enough of these, they start to become as you go through them. But it takes a while to get used to that. Okay, and then there's one other thing I'd like to point out. And this is something that I can't remember. I saw it like one time in all the AP tests I've seen it, and it's possible it appears more often, and that's repeated use of the integration by parts. It is possible that you could end up with something here you could not do, but also was integratable by parts. And so then you could repeat the process until you get it down to something that's sensible that you can deal with. Typically, it happens to do it when you have like an x to the third next to something you can't deal with. Well, then after you do the integration, it's going to be x to the second. You do it again, it becomes x, right? Because when you integrate, the second part becomes a derivative, right? We're taking the derivative of this piece, the x part, right? So as we take the derivative of this, it slowly but surely sinks in power until it becomes something that's doable. Does that make sense? It's traditionally where it happens.
You do the negative 2x, the integral of that.
Integral of negative 2x would be negative x squared. Oh, e to the negative 2x? You would have to use a u substitution. Let's do it.
Isn't that just like negative?
Integral e to the negative 2x dx, right? I know how to do e to the x, so I would go crud. I'm going to u equals negative 2x, right? So du dx equals negative 2, oops, just negative 2, because we're writing it out formally still. So du equals negative 2 dx. I need a negative 2 here, so I put a negative 1/2 out in front. And then I can do 1/2 integral e to the u du. Just e to the u, negative 1/2 out in front, plus c, and then I put u back in.
So for example 3.
Example 3?
Yeah, example 3.
Yeah.
It's just doing it with a single term, but you're still doing it.
Sorry, one more time?
Sign.
They give you an arc sine. One more time, question? I missed what you
Okay,
said.
so for example 3, it's a single term, but they're still integrating my part.
Yeah, well, you can do that, right? If you set dx to be v,
Right.
and then you set arc sine x to be u, you can still technically do that. It's not, that's a trick. So if you want to circle that and say that's a trick that occasionally comes up, again, another one of those things I don't see very often in the AP test. You should be aware of it, but it's a trick.
Can you still integrate it the other way too?
Do you know how to integrate the arc sine of something?
No, I don't.
You know how to take the derivative of it, though.
Yeah.
And that's the trick. If you can recognize, I know how to take the derivative of this, but I don't know how to take the integral of this,
Okay.
that's when the integration by parts can come into play. Because what we're doing with that one feature, is we are integrating, instead of integrating, we're taking the derivative.
Can we do that?
So the part you want to take the derivative of. Okay. Okay, but again, actually, you know what? Let's not do it. And the reason why is I want you to practice normal ones first before we pick the exotic, okay? So go back to example 3 when you've done a few problems. You know, example 2, absolutely do that one for practice. And then go to the back and do a couple of those problems. Because I don't want to focus on a weird kind of quirky one when there's a pattern to all the rest of them. Once you get the pattern, that one will make more sense, I think. Does that make sense? I mean, I'm happy to do it, but